Here's a more mathy example. Let's say we have this relation capital F, which is the ordered pairs in R cross R, or R2, such that y is equal to 1 over x squared plus 1. So the only way x and y can be related to each other is if y is equal to 1 over x squared plus 1. And since we have an expression for y in terms of x, we could rephrase how we define f by saying f is the set of ordered pairs x, comma 1 over x squared plus 1, such that x is an element of R. Remember when we talked about different ways to define sets, there were two main ways. One was something of this form, and the other way was something of this form. So you might want to go back to chapter 4 and remind yourself, what were those called? How did those work? So for example, 1 comma 0.5 is an element of f. Let's check that. So if I do, is it true that 0.5, which is the y, is equal to 1 over 1 squared plus 1? Well, 1 over 1 plus 1 is 1 over 2, and these two things are definitely equal to each other. However, 1, 0 is not an element of f. If I plug in 1 for x, the 1 will go here, and it'll also go here. I'm supposed to get 0 for y. That's not going to happen. So 1 comma 0 is not an element of f. 2 comma 0.2, let's check that. So 0.2 is the y, and we're asking ourselves, if I plug in 2 for x, will 1 over 2 squared plus 1 equal 0.2? Well, it's 1 over 4 plus 1, which is 1 over 5, and that is definitely equal to 0.2. And again, this is just to remind us the different ways of looking at it. So now go ahead and try a few hands-on exercises. Pause the video, give these a try, practice with this new notation, and then come back. Okay. Sometimes we'll consider relations involving finite sets like these. And so the first element, or the first coordinate, I should say, of the ordered pair will come from capital A. The second coordinate will come from capital B. We can define a relation. A and B are related to each other if and only if A minus B mod 2 is 0. Remember that something mod 2 equaling 0 is another way of saying that that something is even. So we could have said this as A minus B is even. So notice that the ordered pairs that appear in this set R are these. So take a moment to check. Is it true that if I take the difference of these pairs of numbers, I'm always going to get something that when you mod it by 2, you get 0? Okay, so hopefully you've checked that. Notice that A is between 1 and 6 and B is between 1 and 4, so we can't say whether 1 comma 5 is in the relation, because 5 isn't even in B here. We have to be careful if A and B are two different sets, which, as we said, is the general case of this. So try this hands-on exercise. You have two different sets. Notice that B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's what the ... is indicating. And the relation is called S. A is related to B, if and only if A divides B. And it says use the roster method to describe S. Your answer has to have ordered pairs in it, because remember, S is a subset of A cross B. So if you didn't have a chance to review section 4.4 and do the 4.4 quiz, hopefully doing that will help you understand our references to all these Cartesian products. Okay. Now there's a slight typo here in the textbook that I fixed. So in the last example, by which they actually mean the hands-on exercise, they say that 7 never appears as the first element, in other words, in the first coordinate of any ordered pair. That's not entirely true, because it is the case that 7 divides 7, right? That was the relation mentioned in hands-on exercise 7.1.4. And then they say likewise 1, 5, 7, and 11 never appear as the second element in the second coordinate of any ordered pair. And again, that's not true because of 7. So 7, 7 is definitely an element of S. But other than that, everything else they're remarking is true.